Yeah, and this is quite important, yeah, important parts of instrumentation in the biomedical world. Yeah, as you know, for example, now when people are in critical condition, it means like when they have heart failure or they have respiratory failure, and they need to be supported by other devices in order to maintain their physiological function and physiological systems. So what are the instruments needed in such intensive care unit as well as in the operating room? See, so we are going to discuss some of the types of surgery and then sterilization procedure, yeah, required during surgery. And then what is in OR, on the operating room or operating theater, and some electrosurgery machine and devices and tester, special care unit, then equipments in ICU and ICCU. Okay, ICU is relates to intensive care unit, while ICCU stands for intensive cardiological care unit. So specific ICU designated for cardiovascular patients. Then bedside monitors, yeah, those monitors usually put located in next to the bed of the patients, and then central monitoring consoles, then ECG and physiological telemetry. And some of this equipment or instrumentation we may have studied them before as individual equipment, but now we are going to study their implementation in ICU or in surgical theater. Okay, so in surgery, there are three challenges in surgery. First is the pain associated with cutting into the body. So basically, surgery relates to any medical action that related with cutting or opening parts of the body, right? Previously, it was mostly done as open surgery, where the surgeon will cut and make an open body cavity. Yeah? But more and more in today's world, the surgeon uh, conduct what we call as minimally invasive surgery, yeah, MIS, using laparoscopic surgery and then conducting the within a small incision hole and insert the laparoscopic tubes, yeah, for the video as well as for the gripper into that small incision hole, and then operates through a video, yeah, in the operating theater. But there is then another new trend, a new tendency, which is using robots to conduct the surgery. Yeah, and most of the popular surgical robots now is called as the maybe Kevin knows what is the name of the surgical Da Vinci. Yeah, the Da Vinci
Yeah,
robot.
Da Vinci.
Yeah,
Yes.
the Da Vinci robot, yeah, that conduct. So in this case, even then, the surgeon is facing a console, a surgical console, not facing anymore to the patient. And then through the console, it is the robotic hands that conduct the surgery, while the surgeon is like operating a game, yeah, it's basically a game, and then doing precise surgery. And future trends maybe that related to surgery, that maybe it's still in science fiction. Future surgery will be conducted by micro or nano robots, yeah, being swallowed and inserted or injected into the bloodstream, and then can go to the particular place where the surgery is needed. So when it is still in open surgery, like most of surgery they now, then usually there are pains when uh, then the patient will have some pain. So this is the function of anesthesia, anesthetic department of the medicines, to really inject and give some some drugs to suppress that pain feeling. Yeah. Then second is there is tendency to bleed, especially with open surgery. Then this is the practice of the surgeon, and to tie off or cauterize the blood vessel, yeah, to close the wound. And infections challenges, yeah, the challenge of infection during the surgery. To suppress infection, you need to use antibiotic drugs or aseptic techniques, yeah, zone of free microorganism, and wear special clothing, yeah, what we call it APD, alat pelindung diri, but not APD, but this is some special surgical clothing. Okay, then these are some types of surgery done. Ophthalmology, this is the treatment of the eye disease. Otolaryngology, this is the treatment of the ear disease. Orthopedic surgery, to treat disease of the bones, joints, on the and other locomotoric organs. Neurosurgery, to treat disease of the brain as well as the nervous system. Thoracic surgery, to treat treatment of the disease organs in the chest cavity. Yeah, the thorax is chest, means chest. Urology treats the disease of urinary system. Obstetrics, to manage pregnancy and delivering babies. Gynecology, yeah, to treat the disease of the female reproductive system. Then operating room personnel involved, among others, first is the surgeon. This is the physician or the doctor that is trained beyond the medical school in the art of performing operation and post-surgical management. Then we have the resident and intern. Yeah, this is the physician assistant surgeon. The resident and intern usually they already graduate from their first medical school. Then they want to do specialization, and usually this will help or assist the surgeon. Then anesthesiologists. This is specially trained physicians to conduct the anesthesia to suppress the pain felt by the patient during the surgery. Then we have the anesthetist, this nurse trained in anesthesia, the anesthesia technician assisting by bringing the supplies and cleaning and maintaining anesthesia patient machines. The scrub nurse is follow the same antiseptic rules as the surgeon. These nurses are responsible for keeping the instruments, tools, and supplies straight. Then the circulating nurse to stay outside of the sterile zone, keeping records, obtaining supplies, and preparing the drugs. Monitoring technicians. This is where we, as biomedical engineering, can play a role actually, yeah, to operate the physiological monitoring equipment, but also to maintain the physiological monitoring equipment. Until now, for example, this function is in the hospital mostly is done by biomedical technicians, yeah, from diploma graduates. Then cardiovascular technicians, this is trained to operate and perform elementary maintenance on a wide variety of physiological monitoring and measurement equipment, like the intra-aortic balloon pump, the heart-lung machines. When the surgery involve operation in the heart or the lung, then the blood needs to be the circulation of blood need to be redirected temporarily to this heart-lung machine, which is basically function as an artificial heart or and lung. The blood gas machine and etc. Perfusionists, this is technicians who mainly operate the heart-lung machines. Orderlies and nursing assistants perform menial to semi-skilled work in the operating room. So any devices or equipments being brought into the operating room needs to be sterilized first. This is where sterilization happens. So sterilization is the process of killing microorganisms on the tools, instruments, and other objects used in the surgery. Because without sterilization, when they still contain some microorganism, then infection may occur, yeah, during the surgery. Several different methods in sterilization includes using steam heat, yeah, the dry heat, gas, then using liquid, then all using radiation. Steam sterilization uses autoclave like this, steam autoclave. We have also in our lab, yeah, but more for sterilizing waste, yeah, before we throw waste that may come from like pipette or whatever, pipette tips, etc. Yeah, that has maybe DNA waste or blood waste, etc. We have to put them first into the steam autoclave. Yeah, this is a pressure lock chamber with a high pressure, and then applying temperature excess than 100 degrees Celsius. Objects are wrapped in a double thickness linen or other porous material with the application of marking tape. Then steam sterilization, this includes using autoclave, 3 periods. First is the vacuum period. Air is withdrawn from the chamber to form a vacuum. sterilization period, where superheated steam is introduced to the chamber at 120 degrees Celsius for 15 minutes, and or 144 degrees Celsius higher temperature as shorter period, 2 minutes. Then the post-sterilization period, this is then when the steam is withdrawn to allow the pack to dry before readmitting room air and unlocking the door. Okay. Then there is the dry heat sterilization method to allow sterilization in room air, but this is less effective than the steam sterilization. The room air and room pressure is required, yeah, so 160 degree for 120 minutes, 2 hours, or 170 degree for 60 minutes, or if you want shorter period of time, then you increase up to 180 degrees Celsius. Then other sterilization method is to use gas sterilization using ethylene oxide and formalin gases. This is actually dangerous gases, yeah, for human. Exposure to gas for 10 to 12 hours and allowed to fan for 24 hours to get rid of the gas residue. This is more difficult to use than steam or dry heat sterilization. This sterilization using gas is used for objects that cannot tolerate temperature higher than 60 degrees. For example, like plastic, rubber, sharp-edged metals, yeah, like the precision surgical knife itself. Because if you heat it up too hot, then there might be deformation. Remember, you already have biomaterials, right? There will be elongation, etc. Deformation happens in the structure of the knife or in the plastic or rubbers. So to avoid such destruction in the object, we use gas sterilization. Liquid sterilization uses antiseptic liquids. Objects are immersed for 30 minutes to hours, yeah, inside the liquid. Then radiation sterilization. This is ionizing radiation. Use gamma and X-ray from cobalt-60 source, yeah, and exposed to radiation as long as 24 hours. I'm not sure if it is commonly used in our hospital, but they are usually used for in the factory, or in the factory or in Batan, our nuclear agency. Usually, when during the packaging, some of these device equipment have been packaged there, and then after they are being sterilized using this radiation sterilization. Of course, the good thing about radiation sterilization is it does not need any antiseptic, does not need any very high temperature or very high pressure. But of course, you need a radioactive element. Okay, now we introduce some of the operating room equipment. Electrosurgery machines. So this is radio frequency AC generators that produce current that has high intensity enough to cut tissue and or to cauterize bleeding blood vessel. Cauterize means to heat up and then they close the bleeding closes, yeah, through that the burn through the burnt wound. Then light source also needed in operating room. Normally they use quartz or halogen lamps, 110 or 21 volt, 240 volt in our case in Indonesia. Used with fiber optic endoscope to view inside the patient's body through opening or surgical incision, and to eliminate surgeon's headlamp, yeah, where in the head cap of the surgeon. Suction apparatus. This is used to remove blood, mucus, and other material from patient body and mouth or the surgical wound. Anesthesia machines control and deliver the oxygen and the anesthesia gas to the patients. ESU is an AC source that operates at radio frequency, electrosurgical unit, typically 300 to 3000 kilohertz, and it is still expensive. Yeah? So if you can make a low-cost portable ESU, that will be very useful, because until now, even complex surgery can only be done in big hospitals, in big cities in Indonesia, for example. But in remote regions, it's very difficult to do a complex surgery. So it is our challenge as biomedical engineer. For example, if we can develop a simple operating room operating theater with low-cost machines like low-cost ESU. Yeah. Two electrodes are connected to the RF power generator. One is active and one is passive. So the active electrode is designed to form a probe or tool for manipulation by the surgeon. The small cross-sectional area compared to the passive electrode causes in greater current density. This difference in current density will cause the tissue underneath the active electrode to be heated to destruction. They'll be heated and then either for cutting or for cauterizing. Cauterizing is to close the wound by burning. Passive electrode is placed beneath the buttock or the thigh. So this is how it looks like. This is active electrode, which has very small cross-sectional area, and the lower part of is the return electrode, which has a wider area. And between them is the RF generator, radio frequency generator. The heating is due to the power dissipated tissue calculated by this formula. The power equals to the rho, the resistivity of the tissue, times the volume, times the I square, the current density, I square, ID square, in ampere per square meter. So this is how it's used. Yeah? For example, calculate the power dissipated in 0.2 meter cubic of tissue that has a resistivity of 1.6 thousand ohm meter if the current density is 0.3 ampere per square meter. The answer is 41.6 watt. Okay. To test that for electrosurgery machines, damage or misapplied patient plate will cause burns. Danger to the surgeons are minimal, but there is a possible shock hazard if there is a hole in the surgeon glove. Yeah, because it is electrode. Yeah. So if your glove is has a hole, yeah, the electrons may jump to your skin and then create some electrical shock. ESU machine is inspected during a dummy load resistor to simulate the patient resistance and a thermocouple radio frequency RF ammeter. Thermocouple RF ammeter measures the current through the dummy resistor with a 0 to 1.5 ampere or 2 ampere for high power range, or 0 to 500 milliampere for low power range. So this is the tester like function as a calibrator, yeah, similar like what Christo made during his internship in BSN, yeah, to develop a calibrator. But this one is for ESU, electrosurgery machine. The advantage of tester for ESU, electrosurgery machine, is the RMS reading provide actual output level, but the disadvantage it is more expensive than other types of meter. No linear scale, very crowded at the low end, making it difficult to read the low power levels. Okay, in special care units now, we move from operating room to the ICU. Yeah, either ICU or ICCU, intensive care unit or intensive cardiovascular care unit. Usually it will have low nurse to patient ratio. Okay, it means the patient has more patient than the nurse. That's therefore equipment and resources is needed to take care of the critically ill patients. The wards is having a night shift with 50 patients per one nurse. Nurses are usually highly trained to handle the emergencies. Medical surgical emergency team for life-threatening situation, code 2 MICU. The key factor for success is the information available to the staff, and this is where the role of technology equipment. So because the nurse does not attend the patients all the time, right? So how do the nurse in the ward can know whether specific patients have problem? So this is the role of technology equipment to give alarm to the nurse in the ward to know to be warned to attend the patients that has specific problem. Okay. Information used by physicians can come from observation or from laboratory or array of electronic equipments. In general, the ECG waveform is always monitored. The heart rate meter, the venous pressure, arterial pressure, cardiac output, and pressure waveform can be observed from the ECG data. Yeah, can be calculated as secondary data from the ECG waveform. Temperature and respiration rate are another parameters which are always also monitored. Some additional equipments include respirator, okay, ventilator, especially for people having problem in respiratory function, like critical COVID-19 patient, they need ventilators. Hypothermia, hyperthermia, this is for people having, hypothermia is when they have very low temperature, for example, when they are in a very cold condition. Hyperthermia is the opposite. Defibrillator for people having cardiac arrest. Tourniquets or people who have been bleeding, aortic balloon pumps, etc. So this is how an ICU, ICCU look like. Yeah? So this is the bedside monitoring equipment, having monitoring ECG, blood pressure, and other vital signs monitoring. And then the bed itself. So this one is the bedside monitor, simple ECG amplifier. Yeah, you can see here on the upper part to ECG wave. Then here is, I think, is the blood rate. Yeah, maybe we can zoom in. Yeah, this is the blood rate. Yeah, the red and the yellow are the blood rates. This one, I'm not sure what they are. Anyone knows? Kevin? No? The yellow and the blue one? So oscilloscope and heart rate meter or complex array of physiological instruments, all equipped with alarms, at least for heart rate. So when the heart rate becomes less and less, and or even sometimes getting to flat line, yeah, so it will alarm and warn the staff at the ward to come immediately. So the common parameter here is ECG. I think this is the heart rate and the numbers here. Two pressure channel, yeah, the red and the yellow part, yeah, systolic. And the respiration, yeah, maybe this is the respiration part. Yeah, this is the respiration part. And temperature. I think maybe this one is temperature. There's less varying parameter is the temperature. Then built-in self-test mode, conduct self-tests and display the results. The character generator displays the numerical data along the signal. This is the numerical data. And it has ordinary ECG circuit or pressure amplifier. ECG setting can be in diagnostic mode. Yeah, is ECG diag. Frequency will be 0.05 and 100 hertz. Or in the monitoring mode, yeah, where it needs lesser frequency, yeah, than when monitoring continuously, 0.05 and 45 hertz. So this reduces the effect of muscle artifacts and patients' gross movement artifacts. So will not be affected by the movement of the patient. And can also display EEG or photoplethysmograph, yeah, SpO2 content of the blood. Then there is in bedside monitor can have also cardiotachometer, the heart rate meter that provides an analog or digital display of heart rate from the ECG signal or the arterial pressure. So from the ECG, they use the QRS discriminator, differentiate and the level detection to trigger signal. Then using monostable multivibrator like this for each one single heartbeat. Then this one goes to the loudspeaker, yeah, to represent the heartbeat. The other one goes to the monitor. Yeah. Analog circuit that display a DC voltage proportional to the patient's heart rate. This DC voltage will be displayed in analog or in digital format. In current day, usually they are all in digital format, yeah, in the monitor. Alarms, this will provide on the bedside monitor to warn the staff of an emergency conditions. Yes, for example, when the resistance is low, no alarm. When it is high, there's high alarm. So this is the one of typical circuit for alarm. If patient's rate speeds up or slows down, the alarm will sound. Lead fault indicator, when a monitor electrode or its lead wire comes loose, the appearance of the display will be either 60 hertz interference, yeah, which is the frequency of the electrical line, or flat baseline, no signal at all. So this can be, if we put this lead fault indicator, it will be indicated and warn the nurse at the ward. Flat baseline can be mistaken by a systole and emergency resuscitation. That's why we need this lead fault indicator. Otherwise, if it gives false alarm, it gives a flat baseline, but actually it is not due to the patient's condition, but it is due to the circuit. Yeah, the lead wire comes loose. That's will be dangerous, and the nurse will apply resuscitation using defibrillator and then give some very high electrical shock to the patient who is still actually not having that problem. So lead fault indicator will help to prevent this occurrence. Then there is central monitoring consoles that allow each critical care nurse to attend more patients, okay, to monitor multiple patients. Without central monitoring, critical care will be one-to-one, then which will increase the number of the personal care, right? The number of the nurses will need to be increased, and this is not possible. Yeah, as you see that even in countries like Indonesia, which we still have basically large population, but the number of doctors, nurses are still less than the adequate adequate number. We lack of doctors, still have lack of nurses and technicians, let alone biomedical engineers. So the advantage of central monitoring console is to amplify the ability of staff to keep track on the situation, reduces the number of nurses and the doctors needed, provide an array of multi-channel oscilloscope, heart rate meters, computer terminal, alarm status panel, and communication system. Like this, yeah, this is the central monitoring console from one single patient. Yeah, multiple parameters are being monitored: EEG, ECG, the pulse rate, respiration rate, temperature, blood gas level, cardiac output, respiratory gas, blood pressure, all amplified. There is an alarm here if there is a critical condition that need to be detected to warn the nurses here. Otherwise, it goes to the recorder or monitor oscilloscope or digital readout. Then it can be sent through via this transmission path, yeah, to this remote nurses. Some signal can go to the manual keyboard near the patient, computer NCRT. Otherwise, it can be transmitted to the remote nurses station, where they will also have the monitoring oscilloscope, digital readout, strip chart, and alarm. So multiple patients can be connected to this single device. The nurse can know which patient are normal, which patient have the tendency to have problems. So no need to have one nurse for each of the patient. This is usually done in very intensive critical unit patient. The telemetry system in ICU, so this is the monitoring function, is performed from remote location. There are two basic forms using radio telemetry, uses small radio transmitter attached to the patients that picks up physiological data, yeah, and transmitted via radio wave to a receiver at the central monitoring station. Then we have landline telemetry using the cable or modem, yeah, audioton or computer-like modem to represent the analog ECG signal and then transmit it over telephone line to the central office. Yeah. This is telemetry system. In radio telemetry, wireless transmission, this is now the commonly used in hospital, sometimes called as the PCCU, post coronary care units, or step down CCU, coronary care unit. Uses tiny VHF or UHF radio transmitter attached to the patient by either belt clip or small sac hung around the patient's neck. But normally now I think uses internet protocol, yeah, IP protocol, Wi-Fi or something like that. Their station is equipped with a bank of radio receiver. They modulate that FM tuned to the same frequencies as the transmitter. The signal can be monitored through computer or step charts of oscilloscope. This is the illustration of a telemetry system from the patient, from the transducer electrode being transmitted using a portable transceiver antenna, and then the hospital has the base station antenna, and then receive and then can be read out. This is a portable telemetry system for critical patient whose heart condition, for example, need to be monitored wherever he is, yeah, inside that hospital. And this is one example of commercial telemetry system. This is from Philips. Yeah, this is, where is it? This is the patients, yeah, so antenna, yeah, patient A, patient B, and then sent through the wireless antenna, then received by this combining network, and then connected to this LAN, the hospital local area network. So, yeah, can be monitored or the data put into database server. In landline telemetry system, instead of using radio frequency, they use telephone line for the data transmission. The signal is acquired from the electrode, are transmitted using to the voltage control oscillator or digital modem. Then the waveform is applied to the input of a signal processor and modulator to be converted into audio frequency modulated or digital signal. Now, mostly I think it's using digital signal in Wi-Fi protocol in current modern telemetry system. Then it is transmitted through telephone line or recorded in a tape. Another modem on the other side of the telecommunication line receive the audio tones and convert them back into binary signal to be displayed on the computer. So this is the modem, yeah, how the old modems work. This is how it looks like. The patients, and then the block diagram, the signal processor transmitted through telephone line, through cable, and then on the other side of the line, it will be again demodulated using a signal processor and then display into the readout instrument. Okay, that will be all for the ICU, ICCU instrumentation, as well as operating room or operating theater instrumentations.